In this video, I'm going to show you how I set up a demo application which creates a user credential system for a decentralized web app. This is all built around Stellar smart wallets. Before we get started, let me just take a couple of seconds to explain what passkey-enabled smart wallets are and how they work. So WebAuthn passkeys are an open standard that's being pushed out across the web. You might have noticed that a lot of mainstream applications are now pushing biometric logins over email and passwords. How this works is it's essentially the device that you're using creates a key pair, and this is stored within the device, sometimes on a secure enclave within that device. The key pair can then sign transactions to confirm the identity of that user. The user's device will share a public key which is open and transparent. The application can then create a challenge which the user has to sign using their private key on the device and then send back. One of the big benefits of this type of system is it prevents credentials being stored on big tech company servers and being subject to data breaches. And where this gets really interesting is that you can now verify Prime 256 signatures that are used in passkeys within a smart contract on Stellar. This opens up the potential for serverless, decentralized authentication systems. And one example of that is smart wallets. So a smart wallet is essentially a contract, the same as any other smart contract that lives on a blockchain network. It's a piece of code which can be called remotely from any device anywhere on the planet. Now these smart wallets can be used in exactly the same way to hold funds for a user in the same way as a normal digital wallet. But the benefit is that you can add business logic, things like social recovery. So you can have maybe like multi-signature system for the user to recover funds if they lose access to their main device. And the authentication for this can all be done via modern standards, such as passkeys. Now bring this all together and you get a far superior user experience where a user can come across to your application and set up an account using biometric data, and then they can just log in with a fingerprint or a Face ID. For developers looking to integrate or experiment with this, there's a high-level API called Passkey Kit, which we'll look at next. Let's start by setting up the Passkey Kit using a demo within that repository as a kind of boilerplate to get started. We can go ahead and clone the repository from GitHub Pale Passkey Kit. That's here. Links to this are all in the description. I use GitHub Desktop quite a bit. You can simply file, clone repository, and that'll create a local copy of that on your device. Once we've got a copy of that locally, you'll notice there's a demo directory here, and that has this will be a .env.example file. Let me go back and revert these changes that I've seemed to have deleted it or moved it. And that'll look something like this. The wallet was in hash, we can leave the same, the contract's the same, we're going to be deploying this test net, so all this is the same. The only thing we need are LaunchTube and Mercury access tokens. So let's go ahead and get them. For LaunchTube, we can just open this URL here, and that will give us an access token. We want to copy this string and put that in there. We don't want to include the brackets. So we've got the string itself, the access token, within quotation marks. For Mercury, we're going to need to set up a free account. Then we can go into dashboard and get access token, and that will give us a new access token here. Note that this token has a lifetime of just 7 days, so after 7 days it will naturally expire. Once we've got that set up, we're going to save this file as .env, and then we can open up Windows Subsystem for Linux, or you can open up a command prompt if you're using Mac or Linux. Yeah, hopefully you can see that. So the first thing I'm going to do is change direction to my mount, C drive, code repositories, Passkey Kit, and then Zephyr. Then I'm going to go cargo, install Mercury CLI. I'm going to export a system variable. We can just copy and paste that from the M file we just created. I've already done this, so that should be fine. And then we can run this command here, which will set up a new repository in the Mercury account. Once we've done that, if we go into the Mercury login and dashboard, you should see this Smart Wallets Next Daemon running. That means that this is set up correctly. Now let's go ahead and install the demo. So we're going to use cd demo, and Tyler uses pnpm. So if you haven't got this installed, you can do sudo npm install -g pnpm. This is an alternative package manager for Node.js. If If you haven't got npm installed, you'd also need to install Node.js. I think you probably install this with Node.js as well. We're going to run pnpm install. So build and pnpm run start. And if all goes well, we should get a local dev server set up and running, which will give us live updates. Brilliant. We can copy this URL into a browser. And you can see here we've got a basic web application which includes authentication using Passkeys. So let's go ahead and register an account. Give this passkey a name, call it James. I'm going to create a new passkey. It's going to ask me for my Windows security login. Sometimes it asks you for face recognition or other kind of biometric sign-in methods. There we go, we've got our smart wallet address right here. This is a C address. This is a contract which is actually on the Soroban network. If we click get balance, we can see we have 0 XLM, but because this is running on testnet, we can actually request some funds. Let's go add funds and then get balance again, and we've got 100 XLM. Next thing we'll do is copy this contact address and then go to Stellar Expert, which is a block explorer. Switch the network to testnet. Let's go zoom in here. Let's get rid of this for a second. And pop in the address right here. Now, you can see we've created this contract. And if we go to interface, we can see the contract functions here. So we've got constructor function, add signer, update signer, remove signer, update contract code, check auth. We've then got some custom structs, enums, and errors. Now, the beauty of these smart wallets is that they're essentially just contracts. You can do a lot of different things with them. You can add your own logic to that contract. So you can do things like social recovery, where the users can regain access without seed phrases using trusted guardians, custom authentication, supporting passkeys, biometrics, or other login methods, gas abstraction. You can then enable gasless transactions for a smoother experience using something like LaunchTube, programmable security, which means you can add spending limits or time locks or multi-signature rules, so that you can actually kind of implement logic to the security of that wallet. You can create restrictions on how funds are moved within the wallet. You can implement session keys to allow like temporary permissions for safe limited use for other users, or some kind of role-based access system to grant different permissions to users or devices. And you can integrate all of this within the growing ecosystem of DeFi and Web3, which is all being built within smart contracts on decentralized networks. If we go back to the GitHub repository, we can see there's the contracts folder here, and then we can go into smart wallets, source, lib.rs. And if we scroll through this, we can see the same functions here, add signer, update signer, that we saw in the contract interface. We could go in and modify these functions or add new functions. There's an example in the tutorial which is linked to where we add a moderator function. So you can essentially just create this moderator function to give a user moderator privileges within the web app, and that is stored within their contract. The one thing to note is that by default, these contracts are upgradable, and they're upgradable by the user. So you do have to be careful with permissions, because any logic you add within the smart wallet, if the user owns the permissions to upgrade that wallet, then it means that they can change the business logic. So they can upgrade the smart wallet to their own version, which has completely different business logic to what you set out as a developer. If you did want to update any of the logic within these smart wallets, you need to rebuild them, redeploy them to the network, update the WASM hash ID and the contract ID within the settings files, and then rebuild the bindings for the web app. The other option is to build on top of these contracts and create decentralized applications which are compatible with smart wallet contracts. Things like set41 tokens can already hold a token balance for a contract ID, so it means they're already compatible with all the tokens that are already out there. You can simply have a smart wallet hold a token balance, and you can send funds to and from these passkey wallets. From a user experience perspective, it's a giant leap forwards for Web3. You don't need a user to download MetaMask, set up a seed phrase, or kind of link their browser wallet to the decentralized application. You simply just get them to register and sign in using a Passkeys wallet, which is stored on their device. I think we're starting to see a shift already in mainstream applications from kind of email and password credentials through to passkeys and biometric logins. Now, Web3 has the option to decentralize this and create these applications which don't have a centralized backend. They don't have a database or a data store. You can simply store all the business logic transparently on an open ledger. I hope you've enjoyed this video. If you want to learn more about Passkeys and building these smart wallets, then there's a full tutorial and developer resources linked in the description. Thank you for watching.